Hi guys, welcome to your Unit 7 Lesson 3 notes on adding and subtracting polynomials. By the end of the day, you'll be able to add and subtract polynomials. Now, when we're dealing with things like x squared plus x plus 1, it gets pretty abstract. So instead, I like to use tiles. Now, we don't have physical tiles because this is a video, but I'll just kind of draw them to help you imagine what it would be like. So we have like a square tile because that's an x by x makes x squared. Or you have like a rectangular tile that's like an x by 1 tile that represents like 1x. Or you can just have like one thing. So that's what each of these tiles are going to represent here. You've got an x squared, you've got an x, or you've got 1. So if I wanted to represent 2x squared, that would be 2x squared tiles would look like this, plus 3x tiles, plus 1 tile. So you get 2x squared plus 3x plus 1. But if I'm going to use negatives minus, I'm just going to, what's it called? I'm just going to represent them all with red, because red is minus. So to take away a minus, or to take away an x, or to take away a 1, to take away an x squared, minus 1x squared is 1 squared, 1 red square tile, 1 red rectangular tile is an x. Oh, but here we have 2 of them. Minus 2 gives 2, and minus 1 dot looks like that. So I will be drawing that kind of idea here. So notice that red tiles are used to represent negative terms. So as we add and subtract, I'm going to be using tiles and moving them around to represent the different terms of our polynomials. We're also going to be using something called a zero pair. Now, a zero pair consists of a number and its opposite. So that's, if you were to add them up, they would cancel out to 0. So like 1x squared minus x squared cancels out to 0. Or an x minus x, x minus x, those cancel out to 0. Or 1 minus 1 cancels out to 0. So that's what I mean by a zero pair, is two numbers that cancel out to 0. I'm going to walk you through a model, actually. I'm going to let you read this through. No, I'll read it. I'll read it with you. You got time. Okay. So if I want to represent this equation, or this expression, this sum, x squared plus 2x, if I want to represent x squared plus 2x minus 3 plus x squared minus x plus 4, then I can take my tiles and add them up together. So you see I've got my x squared plus 2x minus 3 and x squared minus x plus 4, and I'm going to combine them all together with their like shapes. So I've got all my x squareds together. I've got all my x's together. And I've got all of my 1's together. Now I'm going to see what cancels out. So let's see. Oh, I've got an x and an minus x. That cancels out. I've got a plus 1 and a minus 1, a plus 1, a minus 1, a plus 1, a minus 1. Excellent. So that leaves me with our final answer, which is 2x squared. I've got 2x squareds. I've got an x and I've got a 1. So our final answer here is 2x squared plus x plus 1. So when you ask, hey, what is x squared plus 2x minus 3 plus x squared minus x plus 4? Well, that's equal to negative 2x squared plus x plus 1. And that's what we're going to be doing today. There are a bunch of different methods. If you're a visual person like me who likes to see the picture, you can use the picture. Otherwise, there are 3 different methods you can use. So there's like the picture version, and then one kind of mathy way, and then another kind of mathy way. But each of those methods have have steps in common. But anyway, The three methods that we're going to use, there are three methods, is you can use tiles, which are the pictures that we've used. You can group like terms, or you can just write in a column form. I'm going to show you what all of those look like right now. So first, let's represent this guy with tiles. First, we'll need 4x tiles, gives us 1, 2, 3, 4, minus 1 tile, so minus a dot. And then we need to have 2x tiles, so there's 2 of them right there, and 5 1 tiles, 1, 2, 3, 4, 5. If it helps, you can also like write in what these stand for. This is an x, 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 giving us 4 x's and a minus 1, and then x, and then 1, 1, 1, 1, 1, 1, 2, 3, 4, 5. Now we take them and we just add them together. So we need to combine them with their like groups, combine them with their like groups. Now does anything cancel out? Oh, that's equal, by the way. Well, these cancel out. Otherwise, we're left with 1, 2, 3, 4, 5, 6 x's and 4 1s. So that gives us an answer of 6x plus 4. So that's a way to do this, to add some polynomials with pictures, with tiles. There's also completely other ways to do it. Let's remember our problem was 4x minus 1 plus 2x plus 5. And how we group like terms is we want to figure out what do they have in common. Well, here we have an x term, 4x, and here we have an x term, 2x. We also have a 1's term of -1 and a 1's term of 5. So we can combine those together by putting all of our green guys on one side and all of our yellow guys on the other side. Of course, they don't have to be green or yellow, I just happened to pick them. So we've got 4x plus 2x. We've also got -1 plus 5. 4x plus 2x gives us 6x, and -1 plus 5 gives us a -4. Of course, remembering that adding a negative number makes minus, so 6x minus 4. Okay, so here, by grouping our like terms together, we have 4x minus 1 plus 2x plus 5 equals 6x minus 4. There is one more way to do this, and that is to write them in column form. Column is when you, like when you have a column on a building like this that holds the building up, that they're those like vertical thing kind of deals. You know, so you got like this big old colonnade along a building, and you've got little columns. Like that. Okay, those are columns. They go up and down. So we're going to take our original problem of 4x minus 1 plus 2x plus 5. But this time you want to group the terms so they're on top of each other. We're going to make a column like this, and I forgot my plus, so we'll put a plus right here. And now we'll add these guys up, like this. So first we do -1 plus 5, which is -4. And then we'll add up this column. 4x plus 2x gives us a 6x. So that tells us our answer is 6x minus 4. And what do you know, guys? We got the same answer. Wait, shoot. I see what I did wrong. -1 plus 5 is a positive 4. So don't mind me, I can do math. And -1 plus 5 is a plus 4. Haha, okay, we did. We got the same answer all across the board. All right. Now there's another one. We can use that same exact process. We have 2x squareds gives us 2x squareds. Oh, 5xy. We don't have a funny tile for that, but that's okay. We can just, it doesn't really matter. We just make up what we want. So 1, 2, 3, 4, 5. And then, oh, a y squared. Okay, so we got 1, 2, 3 y squareds. Again, if it makes your life easier and you want to write what each of these guys represents, you may. So we've got x squared, xy, 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 x. Oops. Then we have 8 more x squared tiles. I'm just going to copy them. 1, 2, 4. 8x squared tiles and some minus y squared tiles. This is where it's very important to label them. 1, 2, 4. 8 is too many. We need 7 y squared tiles. Now we're going to combine all of our tiles together. Come on, why aren't you moving? Haha, okay. Now we're going to combine all of our tiles together. And what do we get in total? Well, we've got some y squareds that need to cancel out. So this one, cancel, 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 cancel. So what do we have left over? Well, if we get rid of our canceled guys, then that is the same thing as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 x squares. I'm just gonna 10x squared, and we have 5 xy terms, and we have 4 negative y squared terms. So that gives us a final answer of 10x squared plus 5xy minus 4y squared. Now let's see how the other methods hold up. We can group like terms and we can write in column form. So to group like terms, we're going to start out with 2x squared plus 5xy plus 3y squared. That's our first polynomial that we want to add. And we're going to add that to our second polynomial, which was 8y squared minus 7y squared. Now let's find some like terms. Well, we've got some x squareds together. We've got an xy, but just one of those terms. And we have 2 y squared terms. So now let's combine them. Let's put our x squareds first, and then our xy, and then our y squareds together. So that gives us 2x squared plus 8x squared plus 5xy plus 3y squared minus 7y squared. Well, 2x squared plus 8x squared gives us 10x squared. 5xy is all by himself and he's all set. And 3y squared minus 7y squared gives us 4y squared. Oh, hey, that's the same answer. Nice. That was not nice. Good enough. And then finally, we can arrange these guys in columns as well. So instead of writing them out side to side, we line them up top and bottom, but we have to line them up. That's a key idea right here. You need to make sure that the like terms line up. So here our like terms line up with y squareds, that's great, but here they do not. So we need to arrange them so that they fit underneath their partner, much like this. And now we just add up every column. So 3y minus 7y gives us a minus 4, and by y I of course mean y squared, minus 4y squared. 5xy plus nothing is still a 5xy. And then 2x squared plus 8x squared gives us a 10x squared. So our final answer is yet again 10x squared plus 5xy minus 4y squared. Ta-da! Same answer. Ah! What did I do wrong? 3y minus 4y is negative 4y. Aha! Same answer every time. Maybe we should be doing all three methods so we can check our work. Okay, cool. Let's talk about real quick about additive inverse. When you look at add, think plus, but when you think inverse, think opposite. So the sum of a number and its additive inverse, when you add a number and its opposite together, you should get 0. For example, if you have 4 plus -4, that's 0, right? Or if you have 3 plus -3, that's equal to 0. Other additive inverses include -1, which plus 1 is 0, so it's like a -1. Or you could have something like this. You could have like 3x plus 1, but to make that an additive inverse, you got to change all the signs. So 3x plus 1 plus -3x minus 1, that's equal to 0 because the 3x's will cancel out and the 1's will cancel out. Or if you had, you know what, that's good enough. We'll go on. Now, this is how we're going to subtract, because check it out. This is the same thing as 4 minus 4, which is 0. And here we've got 3 minus 3, which is 0. Or -1 minus a -1, excuse me, is 0. So how we're going to subtract is we're not going to subtract at all. We're just going to add the opposite. So when you subtract, just add the opposite. I like to think of it as taking the minus sign and distributing it to everybody. So it says, you know what? That becomes a plus. Here we've got a minus. Minus becomes a plus. This becomes a minus. And that's exactly what we're going to do. We're going to change everything to its opposite. So when I say add the additive inverse of the subtrahend is this second number, which is this guy. Okay, and the minuend is the first number. So let's first just find the additive inverse of the subtrahend. So all we're going to do is we're going to take that second number, which is 2x squared minus 4x plus 3, and to find the additive inverse, that means make it negative. Change everything to be its opposite. So we put a minus, a minus, a minus. Put a minus on everything. So that comes out as -2x squared minus is a plus 4x squared minus 3. Okay, cool. Now that we have that, then we'll add that to our first number. So we have 3x squared plus 5. Since we subtracted, we're adding the opposite of that. We just straight up add the opposite of our second number. You can do this in whatever manner that you want to. I'm gonna go with columns because I like columns the best. So as I look at my columns, I want to combine my like terms. So I want to take everything that's similar. Just kidding, sorry. I'm going to take my x squareds and make sure that they line up. I'm going to take I need some more colors here. I'm going to take my x's and make sure that they line up. And then I'm going to take my my numbers. Oh, that's really close. Yikes. I'm going to take my numbers. Do I have it like a pink? Here we go. And make sure that they line up as well. Using the column method, just gonna, oh, that doesn't quite line up. I need to space this guy out just a little bit. If it helps, you can think of this as saying, oh, this is plus 0x. There's nothing there. Ha ha ha. And that's okay. All right, columns, here we go. 5 minus 3 is 2. 0 plus 4. Oh, I got this. Nailed it. Nailed it before I even said it. 4x. This is a plus 2, right? And then finally 3x minus 2x. Well, 3 minus 2 is 1. I don't need to write a 1. I can just say, hey, there's an x squared there. And there you have it. There's our final answer. X squared plus 4x plus 2. So that's how to subtract a polynomial. Just change your minus. Minus means just add the opposite of everything. There you go. So in your homework, you by no means have to use all of these strategies. You can just pick the one that you like best, and that's great, as long as you have a wonderful time on your homework.